Hi everyone, welcome and thank you for joining us. The Powerhouse acknowledges the traditional custodians of the ancestral homelands upon which our museums are situated, and we respect their elders past, present, and future, and acknowledge their continuous connection to country. My name is Catherine Poltz. I'm the science producer at the Powerhouse and programmer for the Sydney Science Festival. Throughout National Science Week from the 14th through the 22nd of August, we've been broadcasting live conversations with experts to address some of society's biggest challenges and the positive contributions made by science and scientists, covering everything from First Nation science, oceans, climate change, astronomy, computing technology, and coronavirus. If you've missed any of our earlier programs, you can still catch them on demand until the end of August at sydneyscience.mas.museum. Tonight we have our Southern Sky live stream presented by Powerhouse and Sydney Observatory with our astronomy ambassador, Karlie Noon. Science Week is our 1-year anniversary of starting our telescope live stream program, and in the year we've had over 170,000 viewers tune in to learn about the southern sky. Let us know if you are a new or a returning viewer in the comment section, and also where in the country you're watching from. Tonight, like every month, we will view astronomical objects that are visible in the sky throughout this month in Australia. The footage we have tonight was captured earlier in the week. So we really hope that our program inspires you to go outside and look up and feel connected to the southern sky. I'll now introduce Karlie. Karlie Alinta Noon is a Gamilaroi astronomer and science communicator who's worked with audiences around the country promoting Indigenous astronomical knowledge systems and advocating for women in STEM. Karlie was the first Indigenous woman to obtain degrees in physics and mathematics and is currently completing a PhD looking at the gas dynamics of the Milky Way at the Australian National University. A multiple award winner, Karlie was an ACT Young Australian of the Year finalist in 2019 and a Eureka Prize Emerging Leader 2019 finalist. This is our last live stream with Karlie during her tenure as our astronomy ambassador. We've learned so much working with her over the past year and had so much fun building our astronomy programs together. So a huge thank you and welcome to Karlie.
Thank you, Catherine. In the midst of the 2021 Sydney Science Festival, my time as the inaugural astronomy ambassador is sadly coming to a close, and I must put down this wonderful crown that I've been honored to have. I must say bye for now, but not before we have time for one last stroll through the cosmos together. Tonight, we will be going on a tour of my favorite astronomical objects, combining both Western and Indigenous understandings of the sky. Tonight, we travel light years away to explore this wonderful late winter August skies through the wonderful telescopic eyes of the historic Sydney Observatory. Please excuse my misbehaving dog out there. Yama Ningdagaba, Karlie Alinta Noon, Naya Mariyina, Gawe Goe Gumare. Hello and welcome everyone. I hope you are doing wonderfully on this, late winter's eve. My name is Karlie Alinta Noon. I am your astronomy ambassador for one last night. And I am an Aboriginal woman speaking the language of my people, the Gumare people. On this special night, I humbly acknowledge the traditional owners of the lands on which I tread lightly on. That is the lands of the Ngunnawal and the Ngambri people, otherwise known as Canberra, ACT. I pay my respects to all elders and custodians of all lands, skies, and waters. As always, let us know where you are joining us from tonight. Leave us a comment, please leave us a comment. And also let us know if you're lucky enough to be coming from outside tonight. I, like many others across Australia, find myself in lockdown tonight. And, this week, and I know for many others, it's been for many weeks, if not months now. And so with that, I really want to acknowledge and thank everyone who is doing everything they can to help keep this virus at bay, whether you're an essential worker or, just doing your part by staying at home. I also really want to take a moment to acknowledge the emotional and mental toll that lockdown can have. It is so important now more than ever to really acknowledge that and to really be taking care of each other and ourselves during these really challenging times. Now, the team at the observatory, we are well and truly going to be taking you outside tonight. And we've been working hard. The team at the observatory have been working hard. I'll talk a little bit more about that later. But trying to get some beautiful footage for you this week so that we could all stay COVID safe, of course, to bring you, this live stream tonight. So throughout the night, we will be using images and footage that was captured live from the Sydney region earlier in the week. There were 2 telescopes involved. There was a Schmidt-Cassegrain 200mm telescope used, and there was also a 130mm refractor telescope. And again, I'm going to talk a little bit more about that as we see some of that beautiful footage. We'll also be using the wonderful archive that is the beautiful NASA archive, and of course the David Malin Astrophotography Awards, which are just absolutely stunning. And they're going to combine to be able to help us tell some really incredible stories tonight. There will also be a few opportunities to answer some questions, so please write them in. If you can jump on the Facebook live stream, please send questions through, and there'll be a few opportunities to come back to that and answer some of your questions. All right, with all of that out of the way, I think it's time to jump straight into it. Now, there is, of course, no greater object to kick things off, and I'm sure it really comes as no surprise. The first object is, of course, the celestial emu. Now, this dark constellation is a really special feature in our southern skies to many Indigenous people, but I think I can safely say to a lot of Australians, this has now become a really significant part of our skies. Now, this really beautiful constellation emerges from the dark dust lanes that we can see in the Milky Way band that crosses our sky. This constellation can be seen pretty much directly above head tonight, anywhere across the country. And this constellation, we call it Garagai in Gilmore language. Now, its head takes form, and you can see the head in the bottom part of the picture. It takes form in what we call the Coalsack Nebula. Now, the Coalsack Nebula is quite easy to find. It's really close to the Southern Cross. The Southern Cross is just to the right of it, so that can kind of help you find it, with the Southern Cross being, one of the most identifiable objects in the southern sky. And then the emu's body stretches like most of the length of the sky towards the northeast direction. Now, early in the year, we see this big, beautiful dark constellation, Garagai, running. And when it runs, its neck sticks out, much like how we can see it in this image here. Now, when the old people would see this, they knew that the emus on the ground, the dinner one, as we call it in Gamilaroi, they were laying the eggs, and they were the female dinner ones were chasing the male dinner ones in order to do their breeding cycle. Now, the emu in the sky usually appears around April, and it represents that breeding cycle, the female chasing the males during that season. Now, the emus do start to begin laying their eggs, and the celestial emu is a reminder that these eggs are ready to collect and they can be eaten at this time. Then, as the year moves on, we see different variations of Garagai. When the eggs push down to the legs at the end of June, This tells us the chicks are forming inside those eggs. So you need to stop hunting those eggs. It's no longer sustainable to do so for those populations. We now see the celestial emu, which is a male this time, sitting on its nest, incubating the eggs. And this is a really important story for male Gamilleri people, as we can see the significance of the male or the father role in this story. Now, the Gamilleri word for the month of July is Baragai, which translates to emu chick. And I love that because it really shows you that holistic nature that Indigenous knowledges and culture has become known to be. Now, as the year progresses, Garagai changes form, appearing as a featherless emu, crossing country. And that also signals to Gamilleri people to cross country as well, because the seasons are changing. Finally, in November, only the body of Garagai remains, and this signals to us that the dinner ones on the land are at the waterholes. Just a few months later, the annual cycle of the Garagai in the sky repeats, and the dinner one on the land, and for Gamilleri people, it all repeats. Now, the celestial emu features another really beloved constellation, again, by both Indigenous and non-Indigenous Australians. I've already mentioned it, so you're already a little bit prepped for this one, but it is, of course, the Southern Cross. Now, it is undoubtedly not only one of the favorite objects of mine, but it's one of the favorite sky objects for the whole country, I think it's safe to say. The Southern Cross, or crux as astronomers call it, it's made up of 5 stars, and they're located high in the southwestern sky tonight, and it's slowly descending towards the horizon as we creep further into the night. The Southern Cross is positioned close to the celestial pole, making it visible across Australia almost all year round. As such, it has become a really important symbol for a lot of Australia throughout, our history as Australians. But it, of course, also holds significance to Indigenous Australians all across. Again, for my mum, for Gamilleri people, the story of the Southern Cross speaks of Yarran, meaning red river gum, now the red river gum tree. It speaks of the tree being the first spirit tree. Now, this story, it's set in the creation time. 2 men and 1 woman came from the red country and had been shown which plants they could eat in order to stay alive. They did this for a really long time, but eventually a really big drought came in and they began to be hungry. So one man ended up killing a wallaby, even though he was specifically told he should not eat that wallaby because he did not know the law of that totem. He and the woman ate some of it. Now, the other man refused, and he walked across the country and the river until he came to a big white gum. He lay down there and he eventually passed away. Now, a spirit saw that he did not do wrong. He did not break the law and he did not eat that totem. And the spirit put the man in the hollow of the tree. He then lifted the tree up into the sky, and that tree was followed by 2 white cockatoos, and they were screeching because that was their home, that was their roosting place, that tree, and so they chased after the tree. Now, that tree was placed in the Southern Cross, and it eventually faded in the sky, and it faded so that all that we could see were the eyes of the spirit and the eyes of the man who did not break the law. And that's what we see as the Southern Cross. Now, the 2 cockatoos are also in this story. They are the pointer stars that point to the Southern Cross. And we can see that in this image here on the left, those two pointer stars, or those two white cockatoos. Now, this is the story of the first death of man and woman. And it's much like the biblical Adam and Eve story, which I find absolutely mind-blowing. I'm sure there's a PhD in that. Now, the she oak, the trees, they sigh in the wind. They're said to sigh in the wind, and that the gum trees cry tears of blood, their gum. And that is to mourn for the death of the first Aboriginal people. Now, the significance of this constellation to Indigenous peoples was recently recognised by the International Astronomical Union, with one of the stars in the Southern Cross being given an Indigenous name. Now, the name chosen was Ginan, which is the Waterman name for this star, representing a red dilly bag filled with knowledge and special song. So this is undoubtedly a really special constellation for a lot of people in a lot of different ways, which I find really, really quite magical. Now we're going to move on to our next object. It's now time to check out what the planets are doing in our sky. And it's really popping off tonight. It is going off. It's actually been going off all month. If you are an avid sky gazer, you have no doubtedly seen multiple planets even tonight and what they're doing. The first planet we're going to be looking at is, of course, the glorious Venus. Now, the Uluru people of northeast Arnhem Lands, they always knew that Venus was different to other stars. They knew that it travelled across the sky, different to how other stars moved. They called Venus Barnaba, the morning star, who was seen as a creator spirit for the Uluru people. They believed to have guided the first humans to Arnhem Lands. They observed that Barnaba never went too high in the sky and said that this was because she was tied to the land by rope. Now, the Barnaba songline talks about a journey across the top end of Australia. It details many of the land's features, such as the waterholes she encountered on her journey across that land. Because of this, the Barnaba songline acts as an oral map for the Uluru people. Now, the Gamilaraay people, they also knew of Venus. They described it as a laughing old man. And this represents how light can scintillate or twinkle in our skies when our atmospheres have sufficient water mass. And this causes the light to be distorted, kind of how we saw when we saw that live footage earlier of Venus, how that was somewhat moving, those atmospheric aberrations we're seeing there. Now, it's not very common for a planet to experience this effect, this scintillation effect. However, there is one little asterisk. If a planet is low enough in the sky, the light coming from that planet has to travel through a lot more atmosphere than, say, if it was high in the sky. When this happens, when it is low in the atmosphere, that's when it's likely to occur, this scintillation or the twinkling of the planet's light. Now, of course, we just found out and we just learned that the Uluru people, they knew that Venus doesn't go very high in the sky. And this, in a way, helps confirm that observation of the Gamilaraay story of Venus being a laughing old man. Now, Venus is also one of my favorite planets because of a recent discovery, a really exciting discovery involving the planet and a detection of a chemical called phosphine in its atmosphere. Now, phosphine is a chemical compound that occurs naturally here on Earth through the breakdown of organic matter, and it's often done through a type of bacteria. Now, these bacteria, they don't really like oxygen very much, and so they live in really oxygen-starved places. Now, examples of this are in the form of, say, decaying human flesh, or even intestines they can be in. Now, this chemical can also form through industrial processes. And so it's really interesting to find this chemical on Venus in its atmosphere. And researchers currently don't really have a great deal of explanation for it, suggesting that there's something we quite don't understand yet. Now, it was detected in clouds 50 to 60 kilometers above the surface of Venus, where temperatures are around 30 degrees. Now, that sounds lovely. I live in Canberra. 30 degrees sounds so lovely right now. In contrast, the temperatures on the surface of Venus are about 470 degrees Celsius. So the temperatures and the conditions are much more pleasant in this high atmosphere of Venus. Now, life on Venus has been spoken about for a really long time, as many planets and life has been spoken about. However, since the oceans on Venus boiled away a few billion years ago, it's unlikely that we'll find any life there anytime soon. And, Venus is often said to be very similar to Earth in many, many ways. And funnily enough, Venus's oceans did boil away because of greenhouse gases and the greenhouse effect, and something that's called the runaway greenhouse effect. So let's just hope that Earth doesn't one day start to look like Venus. Let's just pray for that one. Now, on that kind of spooky note, let's move on to our next object. We're still looking at planets, and we cannot leave the planet section without talking about this object. It is, of course, Jupiter. Now, if you know me, you know that I absolutely love this planet. It's one of my favorite tattoos. I can quickly show you, although if you know me, you've probably seen it as well. And I think it's just absolutely phenomenal. It's such a... Let's get into it. Let's see why it's phenomenal. So the Gumari people, they thought of Jupiter as, again, a star that wondered, acknowledging that its its behavior was actually different to other stars. Now, Jupiter again does wander like other planets, and its cycle, its journey around the sky takes about 11 years to get back to that same initial beginning place, original spot. Now, the Ulai people, who were neighbours of the Gumari people in New South Wales, they considered him to be a wandering boy, just, wandering around the sky. Now, his mum, Gunny, the mum was the sun, and she didn't really like him, a little bit awkward. She disliked him so much that she would spear him, and she would send men to spear him, sending him down onto the ground. Now, this story likely describes Jupiter's motion, as it appears quite low several times within that 11-year cycle that it has around our sky. Now, a really cool coincidence from this story is the detail about the sun, Yare, being Jupiter's mum, or Gunny. Now, this is interesting because what we know from planet formation is that planets are created from the materials that has been ejected from that host star. So really, the sun is all of our mums, all of our Gunnies. And I just think that's a really, really cool coinciding coincidence there. Now, Jupiter is the 5th planet from the sun, and it is also made entirely of gas. It is the largest planet in our solar system and one of the brightest objects in our sky, behind the moon and Venus and Saturn, which you can beautifully see tonight. Now, as you can see, there are these bands in the planet, and they tell us information about the stormy atmosphere of Jupiter. Now, it has 69 moons. It's quite a lot of moons, and it has 4 giant moons, one of which is the largest moon in our solar system, Ganymede. Now, some of these moons are visible this month as they transit in front of the big gaseous planet, and they produce shadows on its surface, which we can see through a telescope here on Earth. It's absolutely phenomenal, the pictures coming out of this month. Now, one of the most obvious features of Jupiter is, of course, the huge eye of the storm, which we could see in that previous footage. Now, this storm has been continuously observed for 150 years. Now, here we can see it in the top left-hand corner there. Now, if you are used to seeing pictures of Jupiter, you might notice that this image is actually upside down. And that's evidence of what type of telescope was used in order to capture this footage. I'm going to ask the audience a question. If you know what type of telescope was captured, was used to capture that image, please let me know. And the hint is that the image is upside down. Now, this storm that I was talking about, that eye, it's been observed for 150 years. And research into the storm has shown that it produces such intense turbulence and such intense waves that as those waves travel up into Jupiter's upper atmosphere, that wave energy gets transferred into heat energy, and it reaches temperatures of about 1300 degrees Celsius. Now, to put this into perspective, the surface of the sun is about 5,500 degrees Celsius. So this storm on Jupiter that has been going on for over 150 years produces temperatures at about a quarter of the surface of the sun. It's quite impressive. And I hope you can now understand why it's my favorite planet. It's just really cool. To view this stunning planet this weekend is absolutely perfect. Jupiter is at opposition, and that means that at the moment, Earth will be positioned between Jupiter and the Sun. Now, during this time, Jupiter will rise at sunset and set at sunrise. So it's out all night for us to look at. And it will also be the brightest we will see it for the entire year. And it has a magnitude of nearly -3, which is quite bright. And it makes it a really good time for looking at and observing and seeing. So I hope you're able to use that information and take a peek of Jupiter. Moving on to our next object now, and it's a new object we haven't really spoken about before. I'm pretty excited about it. We're moving on from planets, but still not too far from home. We're talking about Vega. Now, Vega is one of the brightest stars in the sky, located only 25 light years away from Earth. Now, as we get into the night, that number, the amount of light years away, it's going to increase. So 25 light years away is really, really close. Now, this is positioned in the constellation of Lyra. Vega is a whopping 2.1 times more massive than our sun, despite the fact that it's only about the 10th of the age of our sun. Now, this is really interesting. So we have one star that's 500 million years compared to our sun, which is about 5 billion years old. Now, due to its brightness in our sky, Vega is actually one of the most studied stars, apart from, of course, our own star, the sun. And Vega has an unusually fast rotation, and it goes at speeds of about 234 kilometers per hour. It's spinning. Now, to compare this to Earth rotates at about 0.5 kilometer per second. So Vega's a lot faster in its rotation. And what that has created is this bulge at its center due to those centripetal forces of that really fast rotation. Now, over the years, our sky has changed, and so too has Vega's position in our sky. The Earth has a bit of a wobble to it. It helps to think of Earth as being like one of those spinning toys. And now Earth is experiencing this wobble at a really slow rate. The Earth rotates around its axis, taking a total of about 24 hours to complete. That's one day. But as that's rotating, that axis itself is also rotating. It's doing that wobble. And that wobble, that cycle takes 26,000 years to complete. So it's a huge cycle when we're looking at, the cycles that our Earth goes through, massive compared to, say, our daily rotational cycle. Now, as Earth goes through this really slow axis wobble, our sky changes over that period. So about 14,000 years ago, Vega was once described as being the northern star. Now, due to our shifting skies and those changes, the star Polaris has since taken its place. It's taken the northern star crown. But in about another 10,000 years, Vega will once again be in, that right position to be, the next contender for the northern star and take that crown back. Now, of course, being one of the brightest stars in our sky, Indigenous Australians absolutely knew of Vega. It was very well understood and it had a variety of purposes and uses for Indigenous Australians. One use in particular was to predict the weather and the seasons. Now, in astronomy, the twinkling of stars is again described as scintillation. And that really just means that there's a disturbance of the star's light as it's viewed here on Earth. And that's because of our atmosphere and all that it has to travel through to reach our eyes. Now, for the Torres Strait Islander peoples, measuring a star's scintillation became an excellent way to discern changes in weather conditions. Now, being situated really close to the equator, people living in these areas in the, kind of top end and closer to the equator in general, experienced two really distinct seasons. And they are, of course, the wet and the dry seasons. Now, this is really dependent on two things. There are these things called trade winds, which are really permanent, constant winds that go from the east to the west across Earth's equator. And the other thing is also rainfall. And that's really what determines the two distinct seasons in the top end. Now, these can be observed and measured and predicted by observing the state of a star like Vega. So during the hot and the really dry seasons, these stars were understood to shine really brightly and unperturbed or undisturbed light. And as the stars begin to twinkle and as they start doing it consistently, winds are then known and noticed to begin increasing. And this, of course, is signifying that change in the seasons. The more a star twinkles, the higher amounts of rain that can be expected. This is, of course, due to the fact that if there is high humidity or high moisture in the atmosphere, more starlight will be absorbed and it will be its path will be changed, creating more of a twinkle or a scintillation. Now, due to the absorption of this light from the water molecules, the measuring of star scintillation is a really great technique to monitor, how much moisture is in the atmosphere up above, and to measure those daily weather variations. For more info on this, I'm going to give a cheeky plug here. Please keep your eye out for next year's Sydney Observatory's Sky Guide, the 2022 Sky Guide, because yours truly has written an essay on this that has been put in there. So please check that out if you want to learn more about Indigenous weather prediction techniques. Now, I wanted to take a moment to have a bit of reflection on the time that I have spent as your astronomy ambassador. I first came on board with the Sydney Observatory 1 year ago now, and only a couple of months into lockdown, and only 6 months into the coronavirus outbreak in general. Now, sorry, I laughed because I saw Jupiter is sexy in the chat, not because of the coronavirus outbreak. I'm sorry, I just have to clarify that. Now, everyone was looking for ways to continue engaging with the community across the board, no matter, kind of where you were, and especially using online forums to do so, of course. Now, with everyone at home and, these feelings of boredom and lockdown absolutely wreaking havoc, and as it still, clearly is today, live streams became a really exciting way for us to continue connecting and sharing our sky stories. Throughout this time, we have had to be really adaptable to, the ever-changing conditions, which saw us go through many transitions with each live stream. Through the use of pre-records of the sky carried out by the fabulous astronomy educator, Jeff Wyatt, the fantastic organization of Catherine and Sharon behind the scenes, sifting through the archives to bring you the most stunning images ever made. And of course, the wonderful Beck handling all of our tech needs and bringing it all together. We have been able to bring you these really exciting, culturally relevant, and of course, COVID-safe live streams. I just want to take a moment to really acknowledge the incredible work that has happened over these 12 months and the amazing team that we have to thank for it. And with that, before I get too emotional, I would now throw the mic back over to Catherine to answer some of the questions that you've been asking in the chat.
Hello. Yes, we've had some good questions coming in, and you can keep writing them into the Facebook comments if you're watching on Facebook. First question, Karlie, comes from Harmony, and going back to Venus, she says, do we know if bacteria is on other planets, and have probes ever been sent to Venus?
Yeah, so not really. So probes have kind of been sent past and near, but in terms of the bacteria question, no, we have not detected bacteria on other planets. We haven't detected any form of life. So it's if we could detect that, because this compound it can be interpreted as an indicator that maybe bacterial life does exist in this really nice weathered part of Venus's atmosphere, but we really don't know. It could be a tracer, we don't know. This could also be something that has formed out of, say, geological processes that we don't quite see or experience here on Earth, and so we haven't seen that reaction come from that. From what we see here. So, there could be things that we just don't understand yet. There could be life on Venus or in its atmosphere. We really don't know yet, and that's why it's really important, as you pointed out, to be sending probes there to try and find out this information.
Yeah. We're certainly keep looking, don't we? Kind of going off of that question, another question about Mars, and of course we've been sending rovers and have been searching for life on Mars, but Naomi wants to know, what do you think about the proposed manned missions to Mars and sending people there?
Yeah, I think it's a great goal to have, right? This is an incredible feat. We talk, it's so normalized to talk about going to Mars and, talking about space exploration. And we've just been pumped with it, not only in the past, couple, 5 years or whatever, 10 years, the past 30 years or something through sci-fi. It's so normal to talk about space travel, but to send a human to Mars is absolutely um, unconceivable, the challenges that we need to overcome to be able to do that, in a way that those humans will make it there alive and be able to stay alive for a long period of time after that expedition. The going to outer space, you experience a huge amount of radiation. So being able to deal with that is definitely one of the challenges. The other challenge is our bones, and our bones have formed in a particular way that deals with gravity. So if we don't have that gravity, our bones start to do funny things and they get a bit lost. So look, there's a lot of challenges. I think it's an incredible goal to have, just because the feats that we have to make to get there. But I think, of course, we also have to be realistic as to how big of a challenge this is.
And one last question before we go to our next astronomy target. But Karlie, you've been working on a few different things this week. Do you want to tell us about a special project you have that's being released right now?
Yes, I would love to. So at the moment, if you are loving the astronomy content at the moment, we have just released an incredible podcast. It is called Cosmic Vertigo. It is co-hosted by myself and the fabulous Corey Tutt from Deadly Science. And we have just the deadliest yarns about everything. How the stuff up there affects us down here, and not just me as an astronomer, but all of us. How space affects all of us here. So it's a really great podcast. I had so much fun making it. Oh my god, it was just the best. So it's so weird that it's now a thing that exists in the real world, because it was just so fun. But yeah, if that's, it sounds like it's up your alley, please check it out. We release a new episode each working day. We take a break on the weekend, but each workday you can expect one. And we do silly things as well, like name that space sound, which is a fun way to learn a little bit of, the science techniques that are used in this area, but also just an excuse to have a really good laugh.
I highly recommend it. Well, thank you, Karlie, for our mid-program questions. We have more at the end, so keep them coming, but take us back into space.
Oh, my pleasure. So going back to space now, we have one of my favorite constellations, and I absolutely had to put this in as soon as we kind of decided this was going to be my favorites live stream. This was the one thing I was like, this needs to be in there. I need to talk about this. The constellation is the Corona Australis. Now, the name means southern crown in Latin, and when you see it, you can see why it has this name. It has a very distinct C shape, positioned pretty much directly above head tonight. Now, it's just a little bit west from where the moon is currently located. Now, to the Western Aranet people of the Northern Territory, the constellation was not seen as a crown, but it was seen as a cauldron. Now, a cauldron is a container made out of the layers of a tree and is very common practice amongst different communities. Now, the story about the Coolman constellation is an important one for the Aranet people, as it has really strong links to a significant site on their country. The story of the Coolman goes like this, as told by Aranet elder Ani Mavis Malbunka. The star women were dancing in a corroboree when one mum placed her little boy in a coolamon and sat the baby on the Milky Way. During the dance and the ceremony, this coolamon slipped off the Milky Way and the little boy was lost. The child and the coolamon fell from the sky onto the land, crashing and driving the land up around it. The mother went to look for this missing child, and the mother is now believed to be the evening star. Now, the mother looks for the child in the evening, and the father looks for it during the day. And of course, the father being the morning star. Now, they are both looking for their child day and night. Now, these are also seen as being the same as Min Min lights, something you may have heard of. Min Min lights are generally thought to be these mysterious lights that are perhaps spirits from the other world in search for something. Now, these stars, these Min Min lights, they are seen as these parents. Now, Aranet man Warren H. Williams, he further shares some insight into this story, and he shares that shooting stars are also these very same family members searching for their lost child, whose name is Narala. Now, the place where Narala fell, it's a very significant place to the Aranet people, and it's called Goss's Bluff. And this is, of course, an impact crater in Central Australia. It is the place where many bush foods were created using the special rocks that were made by the falling Milky Way baby. Now, the Coolman shows up during the winter and tells us that women are still dancing in the stars, just like the women on the land are still dancing today. And I'm sure you can see why this is absolutely one of my favorite constellations. Moving further into the galaxy now, and we're looking at the constellation of Scorpio. Now, shout out to all the Scorpios out there. I myself am a Leo, so this is absolutely my month. Great month to have, my favorites live stream. Now, this constellation is positioned just southwest of the moon tonight. Just southwest of the moon and the Corona Australis constellation we were just talking about. And it also features a star, again, another star that has been officially recognized by its indigenous name being Larawag. Now, this is the Waterman name for this star. And this represents, it's a signal watcher, this star, and it tells when different times of the year, such as when ceremony shall take place. Now, in this beautiful image, we can see that shape of the Scorpio. It's almost like, I like to think of it as like a wriggly fishing hook. It has that real hook shape to it, and it crosses over the band of the Milky Way. Now, this is one of my favorites, not because of, scorpions or Scorpios, but because it lies at the center of our galaxy. Now, the galactic center is where the supermassive black hole, Sagittarius A, we call it, that's where it lives. And this is actually the location I am focusing on my very recently commenced PhD. So just a shout out, you'll have to catch up with me in the future to see how that goes, learn all about it. Coming back now, this black hole has a mass of about 4 million suns, but it is confined to a space of about 30 suns. So we're squeezing 4 million suns into the space of 30. So this tells us black holes are really dense, really, really dense. In fact, they are the densest objects that we know of. Now, they are essentially really old, dead stars that have been squished into these tiny little packages. There are many reasons why black holes are cool. I think the most interesting thing being that we really have no idea what's going on inside of them, right? As evident by their name, they are absent of light. We can't see what's going on inside. And that's because nothing, not even light, can escape. So this brings up all kinds of questions, right? We see stars buzzing around black holes at incredible speeds. Some can reach speeds close to the speed of light. These are crazy fast speeds that they're going at. And as they spiral into these dense black holes, nothing passes, nothing comes back out once it passes that event horizon, that point of no return. And that's really the story. We really don't know much more than that. Where does it go? You know, the work of current and future astronomers. Now, a recent paper came out this year from the Institute for Algorithms and Scientific Computing in Germany, and it offers a new way to understand black holes. They suggest that they could be objects called dark stars. Now, basically, they're suggesting that they could be stars that cannot emit any light due to how dense they are. They just can't let any of that light go. And the light is just so stretched out, we can't see it. And really, I think this is really cool. A really great insight into the work that people are doing in this space. And for me, I don't know, it sounds like it's out of sci-fi, which is always, you know, a tick if it's got a little bit of magic to it. All right. Now, as with all of our live streams, we are now getting close to the end and we are getting to our deep sky objects. We don't have long, so I'm going to have to get through this so we can see all of it. Now, our next object is a favorite of all of ours at the Sydney Observatory. It is, of course, the Lagoon Nebula. Now, no secret to, you know, our regular viewers at home. This can be seen directly above head tonight, positioned in the northwest of the moon. So if we throw our minds back, talking about how planets were formed and how Jupiter was formed, I mentioned that planets are created from material that has been ejected from the host star just moments after the star itself was created. Well, these nebula are the very environments in which stars are created. Nebulas such as these ones are also referred to as stellar nurseries, as they can provide the perfect conditions for stars to be formed. You can see at the center of this beautiful luminous source, surrounded by all of these structures, indicating that some star formation is happening there. Now, these lines appear to be dust lines, you know, as we see in our very own Milky Way. Now, the Lagoon Nebula is located about 5,200 light years away from Earth, so it's a bit far away, and it gives off this enormous amount of ultraviolet radiation, making the molecular cloud ionized. Now, ionized is like another word, almost like radioactive. Maybe not radioactive, maybe that's extreme. But this basically raises the energy level, which in turn creates these beautiful colored clouds, representing all of those little interactions happening within the cloud. Now, in this nebula in particular, we can see the unsurprisingly contains a lot of neutral hydrogen, which is the most common element in the universe. And that's what we're seeing in the red colors. And we of course see those beautiful those dust lanes, which just make it just really pop and stand out. Rushing to our next object now, the lagoon certainly shows us one type of nebula, but our next object, it shows us many different types of nebula. Here we have the beautiful cloud clusters of Rho Ophiuchi, located in the heart of the Scorpio constellation. Now, the Rho cluster can be found directly above head and includes the star Antares, being one of the brightest stars in the sky. The cluster is the name of the closest star-forming region to Earth, and it's only about 7,000 light years away. Now, Rho Ophiuchi contains a few different types of stars at different ages, and different variations. We have the pink regions, which represent the emission nebula, and that's when the host star is letting out a lot of ultraviolet radiation, really energizing the environment around it. We also have globular clusters in this cloud cluster. Now, globular clusters, they're not just one star, but they're actually thousands, sometimes millions of stars, all gravitationally bound to each other. And these globular clusters are really exciting as well because they're old, they are ancient. They're almost as old as the universe, being about 11 to 13 billion years old. Now, Antares is this big red giant star coming out of a reflection nebula, which is basically saying that it's in a cloud reflecting all of its starlight. We also have some dark nebula, which we saw earlier in the Coalsack Nebula with the celestial emu. And all of this just really combines to make this beautiful image and really offers us an understanding of how stars are born. Now we're going to our last object now, but it's certainly not least at all. It is the pillars of creation in all of its glory. This object also goes by the name of the Eagle Nebula, or M16. It is an open cluster of stars positioned in the northern part of the sky, just to the north of the moon at the moment. The open cluster is positioned in the Sagittarius arm of the Milky Way, which, is just next door, only about 5,500 light years away. Now, observations from the pillars of creation has been found to show X-ray emission, which is really, really interesting, and I'll explain why. So star-forming regions generally have a lot of X-rays due to the newly formed stars, and this produces the conditions hot enough to be able to produce these emissions, which usually occur at about 1,000,000 degrees and above, so really, really hot. However, there is a bit of mystery with this nebula, as it seems to have all of this emission, but really no stars going on in this region. This suggests that maybe this region is no longer able to produce the stars that it once was for some reason. And these are really, the questions that astronomers are trying to answer. Now, this object is actually really close to us, so much so that a supernova would have been visible in this region about 1,000 to 2,000 years ago. And this is where I think cultural astronomy is really useful and really powerful. Supernova can obviously be captured in oral traditions, like the Indigenous stories I have shared throughout my live streams. Our stories are a really great way to capture information about transient phenomena that has happened in our skies. And I hope you have enjoyed all the stories I've been able to share with you tonight. We have one more opportunity for questions. So we'll go back to Catherine now.
Thank you so much, Karlie. Such a wonderful presentation. First question comes from Vega, and they want to know, can you recommend a book or any resources that include some of these fantastic Aboriginal sky stories?
Oh, yes, I can. Look, I'm gonna be a bit unconventional and just grab some books because they're just over there, so I can show you them. One is Dark Sparklers, and this was written by a Waterman elder who has a huge amount of knowledge on the sky and on the stars. The other book is Dark Emu. It has a lot of information. Dark Emu by Bruce Pascoe. A lot of information, not just about the land, but about the sky as well. And of course, with Indigenous knowledge, everything is connected. It's really hard to learn about, say, the sky without learning about the animals and the plants that are here on the land. So they would be my two. But I'm, of course, I have something else to plug. I'm sorry, I've been really busy in lockdown. But myself and the wonderful Gamilaroi sister, Yana, Crystal Dinapali, we have co-written a book with the National Museum on Indigenous Astronomy, which will definitely contain some stories, maybe some stories that we heard tonight, but a lot of other ones as well, and a lot of information about Indigenous astronomy in general. So I would recommend those books. I changed my mind. I won't actually grab them now because we don't have much time. But yeah, Dark Sparklers, Dark Emu, and keep an eye out for our book coming out in May next year.
Amazing. Next question comes from Kathy, and she wants to know, how long does it take to form a star? How do stars form?
Oh, that's such a great question. It takes actually not that long, but that again has little asterisks. I'm an astronomer, and not that long to an astronomer is actually really, really long. So if we think about our star formed around 100 million year period. So first what happens is we have one of those beautiful clouds, those clouds that we saw tonight, like the Lagoon, and eventually it gets so dense, all of that gas in that cloud, that it sinks under gravity, and we get what we call a sink particle, and that's basically the collapse under gravity, and that's the very start of a star. And that is eventually the core of the star. And as that goes on, it not only lets out a bunch of radiation and a bunch of gas, but it also takes in a bunch of gas as well, and it grows and it grows. So that process of, spewing out a bunch of material and also pulling it back in, that goes on over 10 to 100 million year period. If we think about the age of our sun's nearly 5 billion years old, and so it was a very short fraction of its life that it was going through that formation period.
Great. Another question from Jackie, and she wants to know if you can recommend any tips or tools to actually finding some of these objects in the night sky.
Yeah, that's such a great question. Thank you so much for asking that. I think this is really important, right? Because it's not easy to find things in our sky. The images we see on Google look nothing like what we see with our real eyes in our real backyards. So it definitely helps to have something. The essential tool is an app. So Sky Guide, Sky View, there's a web-based one called Stellarium. That's a really great one as well. These apps are, for me, necessary. Even with all my experience with looking at the sky, I still need to be orientated myself sometimes. So these are really helpful, especially if you're finding new objects, to help try and find out what part of the sky you're looking at.
And so many of them are free or just a few dollars. They're really accessible.
Yeah. I was also going to say, of course, the Sky Guide, the Sydney Observatory Sky Guide, which I use to create all of these live streams, and have a huge amount of information in them, and sky maps and everything.
Last question, Karlie, but We have another program tomorrow with you, tomorrow morning. Can you tell us a bit about Disordered Cosmos and what you have planned?
Oh my goodness. Yes, I've been looking forward to this, and honestly, it's so exciting. So I will be interviewing. I'm putting my interviewer cap on tomorrow, which I'm also really excited about, to interview the incredible Dr. Chandra Pescott Weinstein, who of course wrote the book that only recently came out, Disordered Cosmos. Now, this book is so juicy. It goes into really, real theoretical cosmology, looking at dark energy, dark matter. What is our universe? Why is it expanding? These really, really fundamental questions that we really have no answer to. And, they're kind of blocking the way from us going any further. So these really important questions. She also talks about the impact of science on us as humans and people, and how science has been used throughout history. It's an incredible book. I read it in 2 days straight. It's a big book, and I'm not a big reader, so that should tell you how engaged and just amazed I was at this book. So we're going to be talking all about that tomorrow, talking about what it's like being a woman of color, being, one of the first astronomy professors in the world, and what that journey has been like for her. So that's happening tomorrow at 11 a.m.
Amazing. Well, thank you, Karlie, so much for sharing this amazing program with us. And it's been so fun working with you this past year, and we will definitely have you back. You can't get too far from us. But I wanted to put it to you. Is there anything you'd like to send off on?
Yeah, definitely. Oh my goodness. Oh, look, my time as the astronomy ambassador has been one of the best adventures of my life, honestly. The support you have all shown me has been phenomenal, and I have felt so incredibly welcomed the moment it was announced. Being someone who is not often represented in spaces like this, it has really been life-changing to not only be invited, but to be so openly accepted and welcomed. So thank you so much for letting me be your astronomy ambassador, and for going on so many space adventures with me. There has never been a more perfect time to be connecting with our outside world, and to appreciate it for all of its beauty. So I just really want to say thank you so much to the Sydney Observatory for having me, and thank you so much for everyone who has tuned in at one point or another. That's it from me. Yalu, love you all.
Thank you, everyone. Thank you so much, Karlie, and we hope you all have a great night, and we see you back tomorrow.